All right, and now we're ready to kick off our next session, 3D scanning for jewelry with Fernando Cortez. During this session, Fernando will show a 3D scanning demo with the new B9 Scan 500, share the benefits of integrating 3D scanning into your jewelry manufacturing workflow, delve into the wide range of benefits of integrating, delve into the wide range of applications for 3D scanning in the jewelry industry and more. If you have any questions, please type them into the Q&A tab or chat to the panelists. If we have enough time, we'll address them at the end of this half-hour session, and if not, and we need to just roll into our next session, we'll try to circle back and answer them during the open forum Q&A after we wrap up our final presentation of the day. Here's the agenda for this session. We will start with an overview of the scanner, move into applications and benefits, then go over basic operation, and finish off with a demo. All right, Fernando, why don't you go ahead and introduce yourself and take it away from here. You can just go ahead and let me know when you're ready to move on to the next slide.
For the jewelry industry, for the past 18 years, I own and operate a retail jewelry store, which is now run by itself. And now I focus on manufacturing for medium to larger companies where we do CAD design, 3D printing and casting. And this is where we use the majority of B9's products. So I'm going to be walking you guys through how we use the B9 Scan 500 here in our office. It's a great tool. It's one of those things where you really don't know how versatile it is until you have it. So yeah, let's move on. And we have a lot of stuff to cover. So hopefully we can get through it, and hopefully it won't go too fast for you guys. Let's get started. So the B9 Scan 500. I'll start off with just some of the great things about it in terms of high quality and accuracy. So this new version does come with 5 microns of accuracy. It is an all-in-one unit, so I actually have it here right behind me. All you need is a keyboard, a monitor, and a mouse, and you are ready to go. It does come with 2 softwares, one which is the initial software that you would use to navigate through the operation, and then it comes with a more in-depth software, which hopefully we may have time to get into. Move on to the next slide. All right, let me just hide this self view here. Okay, great. So a lot of the benefits when it comes to this type of technology is it really just saves time. When you buy different types of equipment, when it comes to a printer, you may think you may have to print X amount of models at X amount of price to then recoup X amount of money. In this case, what this gives you and what it saves you is a lot of time savings when it comes to trying to recreate something that would take hours and hours to do in CAD. Alongside that, just its level of accuracy really removes a lot of the having to redo certain pieces. As most people will design something, see how close it gets, print out a prototype, or even print and cast a prototype to see how close it gets. The level of accuracy that this scanner has really gives me tons of confidence, where once we do a design or once we scan something, I really don't have to double check whether it is going to be as accurate as it needs to be. So one, extremely accurate. And that leads us to basically being able to reduce the amount of errors that we have. Most of the time, if you're doing shadow bands, if you're trying to replicate something, you may have to produce multiple items in order to the best one that fits. In this case, since we do use it a lot for doing shadow bands, we're confident as soon as we get that scan, it's from there it just goes on to a CAD department. They are responsible for designing that perfect curve to contour that ring, and we really find that it's really reduced the amount of errors that one makes because the scan is that good. Now, some considerations when it comes to this technology, I always like to let people know, one how it works. This is kind of like an old school mill where a mill can cut only what it sees. It's very similar to the scanner. The scanner can only pick up what it sees. So what I mean by that is if you do have a gallery heavy style ring, or if you have an item that has a lot of perforations, that very backside, if the scanner cannot actually scan that part, it will not create a surface there. Now, in that case, you can do a couple of things, import that into your CAD software, use that as your blueprint to design around, or go into the more in-depth Leo software that comes with this machine. And that gives you a lot more versatility to really design and manipulate an STL file, which one, can be pretty heavy, and two, very difficult to work with. So it does make that part much better. Leading into the next thing is we have customers that purchase this that one wonder, do I need to know CAD before I buy this? And one, no, you don't. We have a lot of people that purchase this. They use it as a standalone piece of equipment. No CAD experience is needed. However, if someone is well versed in CAD, it will take you that step further, and you can dive deeper into the Laos 2 software with a much less steep learning curve. Another thing is that we do scan a lot of gemstones. We scan a lot of odd shaped stones to create a proper mounting for them. And one thing to be aware of is, some stones are going to be more porous than others. This is not something where you would want to, heavily apply a scan spray to a very well-oiled emerald. It's going to be up to the user to know what the stone type is, and what would need scan spray and what would not. So please be aware of that. And for the jewelers out there, this would be no different than knowing what stones you would put in an ultrasonic, what you wouldn't, what stones you would steam, and so on and so forth. Now, one thing we have scanned recently is a wide variety of different bone. And the nice thing is not all items need a scan spray. So the scan spray is really just to create a non-reflective surface, so that way the scanner can actually pick up that surface. So you'd be surprised, a lot of items, if it's not super shiny, really does not need the scan spray, and that'll just lead to a very smooth finish, and not have to worry on if the scan spray would damage whatever surface you're scanning. Next slide, please. Okay, so this was pretty cool. I actually did this. We reproduced an heirloom ring for one of our retail customers, and this was probably like the first week of me getting that scanner. And it came in at a proper time. Customer comes in and says, "Hey, I kind of have an issue. I was inherited this ring. The top part of it's white gold, the bottom of it's yellow gold, and I want to give this to my fiance." And the fiance said, "You know what? I don't like that color combination, but I want to keep the integrity of that ring." And they said, "Well, why should we let you produce this ring?" So in my office at the time, I had the earlier scanner, and I just sprayed it with scan spray, put it into the machine, scanned it, and the customer instantly was able to see the surfaces being appeared on my computer screen. And I gave them the confidence to say, okay, this he's got technology that will allow me to reproduce this piece without having to sacrifice quality. And that's basically what we did. And again, for the jewelers out there, this one was very complex because it did have a two-part insert, which without the scan, it's going to be very hard to pick up which surfaces were the snap to fit parts. And yeah, so it works great if you're going to reproduce something. In this case, not only did it earn us a customer, but it really made what would have been a very difficult job to do off of pictures relatively easy. This scan probably only took me about 6 or 7 minutes to do. And here I am with the customers. They were 100% confident that we were able to deliver on our promise to them. So kind of a really, really cool story. And we use this both on the retail side and also on the manufacturing side as well. Following suit when it comes to reproduction of heirloom pieces, we've also had religious pieces that were very sentimental to the family, and we've been able to scan them and then reproduce them relatively easily. This Jesus head on the upper left actually turned out to be extremely easy, and this was one of those cases where the resolution and the detail came out so good that after we scanned it, we just had a little jump ring on there. We were able to print it and cast it. We did multiples for this family, and it would have took someone who's very well versed in different softwares, ZBrush, Mixer, etc. Hours to do. It really only took us about maybe 15-20 minutes, and we were done with a very complex design. On the lower right hand side, we had another cool project, which one of our customers is family member has passed away, or his father in this case. And he had his military dog tag, which was made out of a very, very thin tin, and he wanted to create a higher quality piece of jewelry. In this case, we were able to scan it. Scanner did an excellent job picking up all the detail. Up from there, we just traced it, extruded a backplate on it, and then we were able to cast it out of silver, and we made a couple of them for the family as well. So again, these are definitely unique ideas. unique ways to utilize the scanner that would have taken many hours, and it really made quick work of this, it's a pretty difficult design. Next slide. Great. So shadow bands. This is probably what we use the machine the most for. A lot of times people have rings that they will, purchase elsewhere, and they do not come with a matching counterpart. In this case, we use this very frequently. And the nice thing when it comes down to saving the time for the CAD designers that are here, you really don't need to do a full scan to get that proper curve to contour around the base part of the halo in this case. So typically for something like this, we would just scan. We would put the stone upside down on the center stone, and then that'll enable us to give us pretty much 90% of the model, which will enable you to do a very quick, simple shadow band. Again, this will just ensure the accuracy, it'll ensure the fitment, and you wouldn't have to produce several of them to see which one, quote unquote, fits right. So great application for this, and we're very, we use this 90% of the time for shadow bands. Great. So for gemstones, this has become increasingly more valuable to us for the fact that a lot of these stones that are custom cut, where they have either a thicker griddle on one side or a thinner griddle on the opposite side. This has ensured that we're going to design a prong that's either not too thin or too thick, and this really helps us reduce the risk of something either chipping or breaking. So this makes very quick work of gemstones. Again, it's just going to depend on what type of gemstone it is that you have, but a high percentage of stones are not affected by a scan spray. In this case, I believe this one was a checkerboard cut citrine or an amethyst, and made quick work of it, and we're able to design a very nice design. And most CAD softwares come with a very basic tools for creating prongs. In this case, having the proper scan out there will allow you to design a very free float prong that is the proper thickness that you would need for, again, thick girdle or a thin girdle, reducing the risk of stone either chipping or breaking. Great. So this was also a cool project. This is actually one that we're working on actively right now. Actually, could you go to the next slide, Rachel? This one will show a little bit more of the detail. So we have a customer that had an old gun grip, and it had this eagle with a snake on a cactus on it, and he wanted us to reproduce it, with high level of accuracy, and we were able to install the full gun grip, which is probably it was a Smith & Wesson, so probably a smaller, Chief model, and the handle itself was probably about 3.5 inches in length, and we were able to, again, scan it. And this is one of those cases where we're basically just going to trim everything but the model itself. We're going to seal it, and then from there just go straight to printing. We're going to cast it, and because the Leo software allows you to mirror things, and we can also mirror the opposite side, and then there we go. We have a left and a right gun grip. And this was, again, one of those things where if you were going to do this the traditional method of taking pictures in 3 or 4 different views, trying to import those into your CAD software, this will make for a difficult task to do utilizing the older methods. Utilizing the scanner, it took us probably all about 30 minutes to get this where we wanted to move it on to the next step. Great. So here, this is going to be a demo video, basically just from start to finish. Basically, what you would do is, in this case, I'm trying to see the orientation of the model here. So here, we always want to orientate the model basically right in the middle of the platform. Just happens to work very well that way. I did spray everything with scan spray to reduce the reflective surface of the ring. And you do have different levels or different amounts of rotation that the build plate will have. We put those as level 1, 2, 3, and 4. And the differences between the levels is how many times that platform will actually stop and rotate to then pick up more data or more data points in this scenario. Once you finalize that, it'll give you what you'll see here shortly in a point cloud. that point cloud will then be rendered and actually provide you with the surface. And that is the surface that would basically be converted into being your actual STL file, which if you scan exactly what you need, you can export that file into your CAD software, work it from there. Or as you'll see here shortly, you could actually use the tools that are provided in the B9 scan software initially to then modify your model, add material, remove material. You could also smooth out a surface if you would like. And these tools, again, are very helpful when dealing with a, with an STL file. As some of you know, an STL file is very difficult to manipulate without utilizing some type of, software very specific for that. Here, all I did is I just trimmed all the extra material that did not need to be rendered, and just hit the render button. From here, it'll convert the point cloud into an actual surface, which you guys will see here shortly. So this is now the rendered version. And again, for what I would need, I would just rotate this into more of a through finger view. I would just trim off the extra material that is not needed by utilizing just different tools here. In this case, I'm just using the polygon line tool, and I'll just highlight what I want to delete and then delete it. Now, in this case, there were like some perforations. So with the tools that are provided here, you can actually do a couple different things. In this case here, I manufactured an error on one of the prongs just to kind of mimic if this were going to be either a repair, just to kind of show off some of these tools. The B9 scan software does come with tools which allow you to add, remove, smooth, or if you are versed in doing some type of freehand sketch work, you can also use a free deformation, which will allow you to add material and manipulate a surface within a perspective view. In this case, you will notice one of the prongs is smaller than the others, and it had a little extra surface. So I used the smooth tool to pretty much remove that little surface that was there. And then from here, you can see that one of the prongs is obviously much smaller. In this case, that we can kind of manufacture an error of a prong that was either broken or an heirloom piece that you are trying to recreate. From here, I just use different add tools to add material. You can choose your spot size. You can also choose your force in which the surface starts to apply it on there. And as you can see, I like to work in perspective. Move the model around, add a little bit of material, then increase the spot size as needed. And it's as simple as hitting your left mouse button, just going in a circle, and it basically will start to add on this material much smoother than one can do even with a traditional wax pen. So as you can see, I'm just adding more material, just trying to smooth it out. And you can stay here as long as you want. You can push and pull, but I find that this is very common for the type of operation that we use. I find that this software is extremely easy to use. It's very versatile, and if you're going to use it for shadow bands or replicating anything, this does a very good job. From here, I just saw a little surface that was floating around. I simply deleted it, and now it's time to get the bottom part of the ring. So there, all I did is I hid that very first scan because it was just no need for it to be on the screen. I then removed the model from the platform, put it upside down, resprayed it with scan spray. And this is a simple example of a level 1 scan. I find that level 1 does provide enough surface coverage to pretty much get all the surface that I would need for the majority of the models. If you were going to scan something that had a lot more peaks and valleys, then I'd probably bump it up to a level 2 scan. That may take a few more minutes to process that information, but you're going to be able to get the information that's needed for that type of scan. In this case, I did the same thing. I trimmed the extra material that's no longer needed. I like to work in these type of looking down and side views. It just makes quick work of trimming these models. As you'll see here, I went back into a through finger view, used a very simple quick tool, deleted everything else that is not important to me. Now, if the scope of work was to design a shadow band around this, after I trimmed this is really all that you would need to grab that curve of those base prongs there. But for the sake of example, we're going to button up this scan so you guys can see, what it's like to actually create that. So from here, I basically just rotated a little bit. I'm happy with the under surfaces that I was able to get. And from here, I always like to select the model, invert the selection to delete any little, floaty pieces that may be there. And then here I brought out the first scanner, basically the top half of it. And now we're going to do a process called registration. We're going to register these two models to create one surface. The way we do that is, I like to orientate both of the models on the left and right side as if you were going to bring them closer together in the middle of your screen, that they would actually create one model. From there, we're going to pick 3 unique spots on both sides of the ring, or both versions of the ring. And what the software is going to do, it's going to use those as like contact points. You could rotate the model around. This is a relatively simple model in my opinion, so I like to just leave it here. By choosing those 3 unique points, it's going to use that info or that data to then map them together. As you'll see on the bottom of your screen, it gives you a general idea of if you're in the right direction. Some rings are going to be site specific. One ring may have more wear and tear on one side, or be over polished or crooked, etc. Once you hit register, it has a cool map of guidance of how close in tolerance you are. As you can see, we're in the blue and green, so I'm pretty confident that this is the proper side. From there, you click merge, and it basically will turn both of those surfaces into one model. Now, as you'll see, that there's a part of the bottom of the shank that did not come out, which is fine. That part just actually did not have scan spray. I will click apply. It will give me that merge surface, and then from there I'll click OK. And now when you return back to your screen, you now have that model together as one. So here I'll show you just a couple different things that you can do. In this case, it could be a repaired ring that is either missing a part, or maybe something you wish to add a part to. There are some tools that will allow you to close perforations or holes in a model, as you're seeing here. And this software, it does a good job of giving you that surface. Again, you can use different tools within this software, which will allow you to smooth, add material, or remove material, until your heart's content. You can, again, push and pull, and once you achieve what you're after. In this case, again, trimming all these little pieces is not crucial, but if you want a clean model, it's very easy to do. As you can see, it literally just takes a few minutes. In this one here, you can either fill it, but I'm just showing you guys how you could trim something off of a model, and then basically use a fill hold tool, which will allow you to then again seal that up without any problems. In this case, we'll just assume that the bottom part of the shank was either damaged, and if you need to add material to it, you'll see that I grab a tool here that we used before on adding material, and then smoothing it out, as you'll see here shortly. Again, it's very flexible. You can choose your spot size, your force in which it's applied. So it does give you a lot of tools which enable you to really manipulate a surface that otherwise would be very difficult to do. Now, in the Layers software, it will allow you to create a surface with a little bit more control. You can use tangent curves. You can have it either keep the curvature, or you can make things a little bit flatter. You can also cut a model into 2, rotate it, weld the surface as well. So if you had something that was either broken on one side and you wanted to make it more symmetrical, it'll allow you to split the model and then rejoin it. So here I'm just going over it with a very simple smooth tool, just to kind of make it a little bit smoother. And that, I believe that concludes the demo there. So hopefully I wasn't going too fast for you guys. It's just a lot of information to cover, and I just wanted to make sure that we kind of get through it all. So hopefully you guys enjoyed that.
Awesome. Thank you so much for that. We're going to go ahead and move into Q&A. So if you guys have any questions, and if you haven't already, go ahead and chat those in. Our first one here says, what level scan do you use for a detailed scan of a ring with small gems and prongs, i.e. halos? And for the religious metal in your example?
That was actually all done utilizing the level 1 scan. So again, I'm very impressed with how little data the software actually needs to create a surface there. And I actually have the ring that I showed you guys in the demo here. And these prongs, these stones are about 1.1 mil, and the prongs are about 0.35 mil, which is pretty small. So to answer your question, uh, the scanner really excels when you have a lot of connected surfaces. Um, the times where I would use something that's more, uh, it's either a level 2 or level 3 scan is really when you have a lot more peaks and valleys or a lot of undercuts. Now, one thing I was not able to touch on is that this software does give you the ability to add an acquisition. In this case, that would be a scan. So let's just say that you're doing a double halo split shank, and there's part of the gallery that you're not able to achieve because of it happens to be right in this particular angle where as it rotates, it misses it. You can actually rotate your model to that desired view, i.e. perspective, and then you can actually add an acquisition in that particular view alone. So that's usually my combo. My combo is how can I get the highest quality with the shortest amount of effort, and that usually ends up being either a level 1 with adding an acquisition in a particular view. Very rarely do we use a level 2 and level 3. So hopefully that answers your question.
And the next question as a follow-up, would that work on the B9 Scan 350 as well?
It would. It would actually. I have both units, and it definitely would. The biggest difference is really just going to come down to the extra microns in accuracy. Um, in my opinion, what the 350 can do is highly adequate for what's going to be realistic within the jewelry industry of what's acceptable. Now, all these examples that were in there, minus the one that we showed you for the shadow band, some of those were done on the 350. And again, the technology excels when you do have a lot of these connected surfaces. As far as the tools that are that come with the software, they both come with the 350 or the 500. The 500 really is going to excel when you really need those micro prongs, or where you really need to know where that little mill grain that's off of a quarter mil beading tool, where things will start and stop. So to answer your question, yes, you can do this on the 350. I also have that unit and we use it daily.
And how do you remove the stones in the model to set stones in the casted model?
Do they mean how do we remove the stones from the scan?
Yes. Yep.
Got it. Well, that would be done more in the Leo software. The Leo software will allow you to select a surface, a couple surfaces, right? So it basically gives you a lot more resolution where you can select individual, polygons of the STL, delete them, and then you would use the tools within the Leo's 2 software to then recreate a surface. The simple example would be, let's just say that you had this mounting, you want to remove the stone, put larger prongs as an example, and then print it and cast it. You would do that in the Leos 2 software, and all those capabilities again are also available if you got the Leos 2 software upgrade and the 350 as well.
All right, and I think we have one more question here. Is the Leo software a full version or limited edition for the B9 scanner?
So it is a full edition, and so this scanner covers a lot of industries. It covers extremely high tolerances in industries, and for the application of jewelry, it has more tools than you're realistically going to need. So for that, to really dive into that, B9 Tech would be able to kind of walk you through some of those things of what it can do. I used to do that in some of the prior training classes, but it's very extensive. It's going to give you a lot of tools that you probably realistically would not need. However, it gives you the ability to kind of grow into that software. I did use it personally on some very complex modeling where again, part of a model was damaged, so we had to get an accurate scan on one side. The only way to split a model, rotate it, make it symmetrical, and then re-weld all of those seams in the filigree was utilizing the Lego software. So it is a very extensive version, and it's going to be a lot more than what you're realistically going to need to reproduce either heirloom pieces, reprinting or redesigning broken links, and or shadow bands.
All right, thank you so much for answering those. I believe that is the end of our Q&A questions for now.